programs, we use anything from Inventor, which is an Autodesk software that industry uses right now to do 3D modeling. There are a couple of different programs out there for two-dimensional blueprints and design, but we have the kids using a 3D modeling program, and it gives them a true real-world idea of what their project is going to turn out like. And the nice thing about Inventor is they can do like tolerance fits and things like this before they ever manufacture the part to know whether the parts are going to fit together, whether they're going to work together. We also, in our architecture program, use Autodesk Revit, which is an industry-based program as well, where the students can actually study the structural design of their buildings to find out whether that building's going to work or not. We use West Point Bridge Builder in our civil engineering program. So all of the programs and the software and the concepts that we're teaching the kids are industry-driven of what they're really doing out in industry today.
The stuff that stands out for us is, in particular, this digital electronics class is geared towards circuit theory and learning about how circuits are designed, digital circuits are designed using Boolean algebra and AOI logic. So it's really a really coming together, a synaxis, if you will, of the arts using creativity to develop projects in conjunction with math and higher level algebra to develop circuits that we use every day in our computers and cell phones and that kind of thing. And what the students discover in this class is that they're designing fairly large circuits that are a very small part of a cell phone chip. And what they discover is this entire world of the minutia, the nanotechnology that goes into our everyday devices.
In the classes, we actually learn how to read blueprints, and we learn architectural standards, and the ADA, we learn that ramps and stuff for handicapped people must be like certain rise over run. Those are things that actually are for real. All of our projects always meet those standards, which is how it is in real life.
This is one of the tools we use here at Friendswood High School in our engineering classes. It's called a three-dimensional printer. What this printer allows us to do is build mock-ups of what the students design. It operates on the same principle as a regular DeskJet printer, except that instead of printing on a piece of paper, it's printing on a powder, a dry powder substance. Each time the printer cartridge goes across, it adds a new layer of printer material to the surface and just builds the 3D model as the printer goes on. So in a matter of an hour or so, the students can take what they've designed on the computer and they can be holding it in their hands to see if it's really going to work or not. It really comes in handy in one of the projects we do in our Intro to Engineering Design class, where the students are going to be divided up into different teams. Each of the different teams has to design an integral part of an overall mechanism. Now what they'll be able to do is they have to learn to communicate across teams and get their dimensions correct, get their sizes and their scales correct, so that when we print it out on the 3D printer, their actual mechanism can come together and be a working prototype of that model.
The conjunction of theory and practice is so important for us, and having their hands in the projects, developing projects, enables them to see and to feel exactly what's going on. And at that point, any theory that they've gotten, any book knowledge, any text knowledge becomes relevant. And that's really what we're after, is making all their math, all their science, all their fine arts, English, geography, history, all of it relevant by giving them projects that relate to everything. And that's really where our focus is on those hands-on projects.